The central cell in the window is the source or processing cell. A new value is calculated for each processing cell based on the chosen function. The newly calculated cell value is stored in the output raster at the same location. Then the window moves one cell further to the right. The processing cell has also moved one cell further to the right. The calculation is repeated for this new processing cell. The result is again stored in the output raster dataset. Then the window moves again and one cell further to the right, and so on until it reaches the last cell of the input raster dataset layer. The neighborhood, see the two images, the neighborhood function on an individual neighborhood, the neighborhood function on a grid. So we can see here three pixel grid, a pixel rectangular, input pixel and output, and here we can see the result of a sum of pixel values which will be given to the processing cell on the center. And on the right image you can see which will be the result of the focal sum to the whole pixel, to the whole raster image. Here you can see the sum of the all pixel values on the left image: 3 plus 2 5, and 8, 10, 12, 13, and 21. Yes, exactly 21. Sum of all pixels, and the result is given to a processing cell on the center, which is the cell where located a pixel with value 2, which is outlined with a black rectangular. Zonal operations. A zone is where all cells in the raster have the same value regardless of whether or not they are contiguous. A zone represents one thematic class, for example, buildings of the thematic raster dataset land use. Zonal functions are similar to focal functions, except that the definition of the neighborhood in a zonal function is the configuration of the zones of the input dataset and not a specified neighborhood shape. So zone in just simple words is a one pixel class. As you remember from the previous tutorials, when we opened the attribute table of a raster, we saw that ArcGIS gives three compulsory attributes to the raster image. It's object ID, it's a value, and its count. So value here is shows the pixel value, value of each pixel, and the pixels with the same values across the whole raster image makes one a raster class. So zonal operations work with each raster class. So they can be neighborhood pixels, they can be not neighborhood pixels. Anyway, zonal operations has a wide and broad impact on the raster. If local operations work with each raster pixel individually, focal operations work with neighborhood pixels. Zonal operations work with pixels which has the same value. ArcMap offers a variety of zonal operations which can be found in Spatial Analysis Toolbox, zonal toolset of ArcToolbox. Zonal statistics, one kind of zonal operation. The zonal statistics function calculates statistics for each zone defined by a zone dataset, based on value from another dataset, the value raster found within a zone. This could be average population density per zone of pollution or most common vegetation type per zone of elevation. The output of this operation can be presented in a DBF table or a raster data set. During this course, only tabular output is created. The zone dataset can be a vector or a raster dataset. The value must be a raster dataset. So as input, we can work both with vector and raster datasets, but the output of the zonal statistics or just zonal operations is always a raster, and we can have as output both a raster image or just a table. With an integer input value raster, the statistics are area, minimum, maximum, range, mean, standard deviation, sum, variety, majority, minority, and median. So if you're familiar with the statistics, you should know about the meaning of these words. If the input values are floating point data type, the zonal calculations for majority, median, minority, and variety are not available. So the result of zonal mean, right? We on as image A we have a pixel neighborhood pixel, or just a raster image with the two raster values, the blue one and the yellow one, and as a result of a zonal of applying zonal statistics, we are gaining two functions, as output one raster image with also two which have the two values, because we're applying two input rasters, A and B raster image, and we have one output raster image after the zonal operation, which calculates the mean for each pixel value of image A. And for instance, you can just calculate manually. 5 plus 5 plus 5 plus 3 is 13, plus 2 is 15 and 20. So which these pixels of the image 2 spatially coincide with the pixels of image A, and they are calculated separately by zonal operation, and after the applying zonal mean, we 20 we divide into 5 pixels, right? Because 5 pixels of yellow, and we will achieve number 4, which is the mean pixel value for image of yellow color pixels. Zonal geometry. As a zonal geometry tool calculates several geometric properties of zones, including the area. The output is in form of a dBF table. And our last one is the global operations. Global functions compute an output raster dataset in which the output value at each cell location is potentially a function of the cells combined from the various input raster datasets. There are two main groups of global functions, the Euclidean and cost or weighted distance functions. In this module, we will only work with the Euclidean distance function. According map algebra, Euclidean distance is calculated from the center of the source cell to the center of each of the surrounding cells that contains the value of no data. Each cell in the output raster contains a distance value, which is the distance to its nearest source cell. Source cells are given the value of 0. Be aware that the output raster is a continuous dataset, not a raster with a floating point distance value. So the Euclidean distance calculates the buffer for each pixel, where the center of a pixel is taken in as a for calculation as the basis, 0 meters for calculation. So here you can see source cells, right? True Euclidean distance. See, the center of a pixel is taken as a basis, and Euclidean distance is calculated true Euclidean distance as a buffer. One also reclassification is not actually belongs to zonal, neither local focal zone or local focal zone or global type of operations. Actually, we can classify reclassification as zonal type of operations. It's something between zonal and global. But anyway, it's a very important and useful tool in Arc Toolbox, because it helps us to make from a continuous raster with no attribute table a discrete raster with attribute tables. Reclassifying data simply means replacing cell values with the